Hey YouTube, it's JP Dillon. Today we're looking at a Fisher, I believe this is a 450T from about 1967-68. This was sent in by a viewer. It's been on my to-do list for a while now, so we're going to finally get to it. He shipped this without the knob, so that just is what it is. And his complaint to me is that it turns on, but there is no sound. And it's going to be a little bit tricky here to activate certain functions without knobs, but because these are really stiff. So let's turn it on and see what it does, if anything here. Yeah, it's even with the main speakers on, all you get is a little flutter from the discharge of the coupling capacitors in the amplifier. So it's not doing anything. Crank the volume all the way up. Still nothing, not so much as a twinge. And let's see, if we go over to FM, we get no meter movement whatsoever here. No twitch, nothing. If we go to AM, we do get movement of the meter. It is sticky. But AM does show some signs of life. Okay, so when we're pursuing this, we're first going to check the power supplies and the regulator and make sure that they're happy. So let's get it open. Okay, so here we are up top. And it's hard to tell if this is the regulator board or if something else is. It might be. I think I'm going to have to look up the service literature I have. But here's your amplifier. Here's your IF, AM and FM and multiplex. I believe this is the varactor system, because this is really a varactor tuner. There is an AM tuning condenser inside of here. But as you can see, the business end on the back, we shed some light on this, is a big fat precision potentiometer for the FM. So this uses a varactor diode system. The diode can vary its capacitance based on what voltage is across it and therefore tune the radio. So that's how they're able to do the electronic tuning on this thing. Is you just have, an advance of the potentiometer, which I believe is motorized. Or they may have an auto scan mode, I forget. It's been a while since I worked on one of these. Let me take a quick look underneath. Alright, so here's the bottom side. And obviously we have our very large power supply capacitors and output capacitors. And this is, that I believe is a giant Zener diode. I believe that is your regulation. We have some discoloration there. So, there we go. There's our series pass right there, which probably does a whole lot, preamp and radio and all that sort of thing. So, what I'm going to do first is power this thing on and take some basic measurements and see where we're at, and then do some more troubleshooting to see why it might be quiet. Okay, so I'm powered up right now. We've still got no voltage or signs of life on anything. So there's 36 there, 53, and 37. It says probably ECB. So we have a 36 volt? 36 volt, that's probably to the preamp. So if we come over to the preamp B plus terminal here, we've got 30 volts. So the preamp should be functioning, at least that's the theory. Just coming over here on various supply resistors to things, I've got 13 volts here and here. I've got 6 volts there. Yeah, it's tough to keep track of the camera sometimes when I'm concentrating on this, so I do apologize. But the preamp, from the standpoint of voltage, appears to be alive. When we come up here to the giant Zener thing, yeah, so we have a 35 volt Zener, it looks like. And then over here, That's 15 volts. That's probably going to be to your tuner. That's ground. 62 volts. That's probably a supply. That's 15 there. 36 there. 62 there. 53 there. And then we got this guy here, which is probably the tuner regulator. 37, 53, or maybe he's the driver for the series pass. I'm thinking he's the driver for the series pass. So we got 54, 53, and 37. So, yeah. So nominally, we can say that the main power supply and the regulated section is functioning. So here's our output capacitors. So there's 29 volts here. And since there was a 62 volt supply, that's interesting. So this one here has 62 volts on it. This one here has 35 volts on it. That ain't right. And these are 40 volt caps. So I'm thinking we may have an amplifier failure, and that's what's causing the malfunction. Let's see, you got plus 43 and 0. Minus 43. This is complementary? What? Yeah, plus and minus 43. So maybe this isn't. Oh, never mind. I can't read. 80 volt cap. This is a 40 volt cap. Okay, so this is the 62 volts that gets regulated down. And this is 29 volts, which probably gets regulated down to the 15 for the tuner. Okay, so that's cool. Again, power supply seems happy. No bulging or peeing capacitors either, which you normally kind of see that on these. Caps look good on this thing. Plus and minus 40. So this is a real DC amplifier. Impressive. Even though the preamp is all single-ended, running on 30 volts. Now, I don't recall if this is like a preamp in addition to being a phono preamp, because sometimes it was a multi-stage thing. Let's see, you're getting 15 volts in, and what else? Yeah, so 15 volts in. So that's probably your phono preamp. Let's check that board up top, see what he does. I think that's the electronic tuner board, though, so it's not going to reveal a whole lot. Yeah, I'm pretty sure this is your electronic tuner board because it's connected to all the seek command functions and stuff like that. That's for your meter. Let's see what's coming in here. Still trying to find a real voltage here. Of course, the tuner's switched off into auxiliary, so that may have something to do with it. There we go. So there's 12 volts there. So all these systems are nominally getting power. And if we come over here to the amplifier, this is that weird design like Marantz has where the collectors are at the output. Either that or it's a semi-complementary using NPN devices. That's interesting. So this set of outputs here, this channel here, isn't doing much of anything. There's no voltage on these outputs. There's nothing. Collector base emitter, nothing there. Collector base emitter, nothing there. And if I come over here to this left channel, I got nothing there, nothing there, nothing there. I got 43 volts here, 43 volts here, that can't be good. And nothing here. And I don't think Let's switch the scope to DC here. Yeah, I get no offset voltage. So what's going on here? This is weird. This is really weird. All right, so in theory, I should have like voltages supplying the transistors. Oh, there we go. So at the board, I've got minus 43, plus 43. Probably same over here. Yep, minus 43 and plus 43. So, all right, here we go. I see. If we zoom in there, that little gray thing right there, that pathetic looking tiny little gray thing, that's a picofuse. Yeah, that's a picofuse. That gray thing right there, that's a picofuse. That's a picofuse. And let's see, the fourth one was like buried underneath here. Yeah, it's buried under the blue wire, but that's a picofuse too. Those are all open. Oh no! Yeah, so the fact that those are open usually suggests that the amplifier is blown up. So let's go ahead and let's turn the power off. And what are they using for output transistors here? These old Motorola's. 020607, 010607. So I'm guessing PNP and NPN. And they all look like stock devices. I wonder if this is one of the early ones that uses the TO3 style Darlingtons. Well, anyways, let's get a meter on them and check them out. So we're gonna see if these things are shorted. Yeah, not good. Not shorted, but trying to make this so you guys can see it here. See the meter. That one could be open. Nah, still looks okay. Nothing shorted yet, which is good. Did that one read? Yeah, so far so good. You know, it's hard to see with my fat arms in the way, but so far, no shorts. Das is good. Alright. So, no shorted outputs. That's actually a relief. But that's definitely why we're not getting any sound, as all these picofuses are open. See, that's what I should have done here, is I should have, let's check the voltage across the junctions. I bet you there's not much of anything at all, because that would definitely cut off any. Yeah, so these are hard off. Minus 0.17, minus 0.05, you know, minus 0.065, you know, nothing. So there's nothing across those transistors. Those transistors are not alive. One thing we can do, since I know somebody was egging me on about the using the signal tracer, let's see if we can spot where the signal disappears to. I'm betting it'll be okay up into the output transistors, and then it will go away. Let's find out. Alright, so we got our gain on our audio generator or signal tracer cranked up. I've got input on auxiliary, so we should be hearing something here. Let's go to the input of the power amp. Yep. Got left channel. No right channel though. Let's see. My balance controls and stuff set right. Maybe I got a dirty switch. Who knows? There we go. Dirty switch. So we got right. We got left. It's cool up to the power amp input. Let's go a little bit forward. Look at the Class A. See if we can turn up the signal a little bit to the amplifier. Yeah, but nothing to the output transistors. Got power supply voltage. Never gets to the outputs. Drivers either. That's kind of distorted right there going out from the Class A driver. Yucky. Nothing on that side. Got it there. Got it there. And goes through our diff amp to here. Yeah, left channel's in better shape than the right, but neither of them are really passing signal. And it's definitely going to be a lot of troubleshooting time to figure that one out. So I'll have to see what he wants to do. Because this is really a layered repair. The good thing is that the transistors in the output stage don't appear to be shorted. But what I do notice is that signal gets to the input of the amplifier here and here. But we don't get much out of the Class A. Like, this is the Class A driver, these little flat pack Motorola looking things. There's no, I should be having something on the collector because that's the drive to the drivers. So I get no drive here. These are ice cold. These should be warm if they're functional, but they're just ice cold. So we have no bias. So there's probably something wrong here. And then if these little differential amplifier packs fail, I need to figure out what I can replace those with, because those could be a culprit. The transistor here could be defective. We could have a support component that's not feeding it the proper voltage. A lot to go wrong here. And this is a very old primitive solid state design. It could be very picky about components, so we have to be careful about that. But all in all, like, let's switch over to, let's see if the FM works. And I can see the meter ascending here, just continuously ascending. That's the automatic mode. Let's see here. It's going to be difficult to get sound out of both. Yeah, I'm not getting... I tune. I'm getting no sound out of the FM. I was getting stuff out of the AM though. Yeah, AM's working. That right channel's crummy. Turn the gain down a little bit here.
Prices, but I'm watching the Dodger game last night. You're going there, you love.
Yeah, so we got issues with the right channel preamp. The FM does not work. We've got a major amplifier failure. I mean, this is like lots and lots of time and money, and it's just going to be a question of how much do you love it, because this is easily $200 to $300 territory, if not more, to get everything right on this. And the amplifier is really the wild card, because people can do without the radio, but if the amplifier is down, like, what's the point? and we don't get anything out of the FM, not even so much as static. It's just very silent. So that could be a variety of things. And when I put it in electronic mode here with the automatic, it just keeps seeking and seeking and seeking and seeking. So yeah, a lot wrong with this one. So I'm going to confer my findings with the owner and see if he wants to proceed with it. Um, and if so, then we'll have a repair series on it. And if not, then it just gets parked and sent back. Anyways, hope you guys enjoyed this. More stuff to come.